Hello, everyone, and welcome to today's webinar. My name is Susan Valakis, and I'm the Training Development Coordinator at NOW, and as such, I bring you these webinars on the third Thursday of each month. If you've missed any of them, you can find replays on our website, nowfoods.com/webinars, or on the NOW YouTube channel. If you have any questions during the presentation today, just use the chat bubble on your screen to type in your question, submit it, and then we will respond to you with an answer by email. Now, today's webinar is part one in a three-part series, The Wonderful World of Herbs. As you know, herbs, botanicals, and mushrooms have been used for thousands of years by herbalists in many different traditional health systems. And they're naturally teeming with phytonutrients that work together to bring about specific beneficial effects as well as overall well-being. And today's mainstream use of herbs is becoming increasingly popular, and there are many, many herbal products to choose from, but it can be confusing about which forms of herbs are right for you. In fact, one of the most important decisions always seems to be whether to use the whole herbs or the standardized herbal extracts. And this can be very tricky because, quite frankly, even the experts are split on the issue. So that's why we decided to do this series on herbs to help you understand the facts and the differences so that you can make an informed decision. Today's presentation will run about 50 minutes and is presented by one of NOW's very own and one of my favorite guest presenters, Neil Levin. Neil serves as our Senior Nutrition Education Manager at NOW, and he is a nationally board-certified clinical nutritionist with a diplomate in Advanced Nutritional Laboratory Assessment. He is a professional member of the International and American Associations of Clinical Nutritionists, and also a member of the Scientific Council of the National Clinical Nutrition Certification Board. Neil serves on the board of directors of the Mid-American Health Organization, or MAHO as you may know it, and he provides a wealth of knowledge to our team at NOW when it comes to nutrition and dietary ingredients. So I know that he has some excellent information to share with you today. So with that, please join me in welcoming Neil Levin to introduce us to the wonderful world of herbs. Welcome, Neil.
And I thank you, Sue. And thanks everyone for joining us. I have some interesting information on herbs and botanicals and added a bunch of products going through our category in the catalog as we've done before. So the first category we're going to talk about is adaptogens, but first I'm going to talk about the herbs and botanicals and some of the details that you may or may not know about them. So a botanical is a plant or plant part, and typically it's something useful for humans. Herbs are a subset of botanicals. For example, fruits would be a botanical, but not necessarily an herb. So we use products from botanicals to maintain or improve health. Various terms are used for these: herbal products, botanical products, phytomedicines is sometimes used. Obviously, we're not going to call our products medicines, but these are some of the terms you'll see on botanicals in the marketplace. And the naming convention that botanists use are a Latin name, which is a genus, and species, which is called a specific epithet, or specific goes into species. So, for example, black cohosh has a long name, Actaea racemosa L, and you'll often see an initial or another word after the genus species. The Latin binomial is another phrase for that. And the L stands for Linnaeus, who first described the plant, so they actually named the plant partially after him. So the genus and species are used with italics, and the other parts of the Latin name are not. You notice the L is not in italics there. So that's a naming convention you'll see on labels as well. And you start with a whole herb. Everything that's in that plant naturally is in the part that's taken. Usually when it's used for make supplements, the whole herb is dried and encapsulated. Sometimes it's processed and extracted and or preserved in alcohol or another solvent. Water, for example, would be a solvent. And crude herbs is the term we use for herbs which have not been extracted. They're minimally processed. So again, it's kind of like the whole herb. You can use parts of the herb this way too, but because you have not extracted them, they're different from herbal extracts. Depending on which plant or plant part is used, or genus species even, the components and proportions of the components in the plant will vary. And in a crude herb, you can extract DNA and do DNA analysis to see exactly what genus species it is. And you could also do microscopic identification of the species, which you can often do on the cellular level. This is not something you can do with extracts. DNA and microscopic identification does not apply to extracts. And of course, any botanical will contain various compounds. There could be literally hundreds of compounds in any plant. And many times we know what an herb can do before we can actively identify which compounds in that plant are responsible for those effects or benefits, or even side effects. So one concept is that some herbal extracts are standardized. One or more components are present in a very specific, guaranteed amount or percentage. It does not necessarily mean these are more concentrated or stronger. It just means they are standardized to a certain marker or markers. And the idea is to get consistency. And it could be simply for identity purposes. It could be for strength. It could be for both in some herbs. But these are called markers, and there's a minimum potency or strength or amount of these markers present in a standardized extract. So a standardization means that the batches are considered similar. These specific chemicals are adjusted to assure consistent amounts in each batch. They might be adjusted simply by selection rather than by manipulating them. But in some cases, they will be manipulated. They might be concentrated or whatever to get a standardization. One example would be on ginkgo biloba. It's a 50-to-1 concentrate that's 24% of ginsengicides. I'm sorry, ginkgosides on there. Now, we'd really like, ideally, that the markers that we're standardizing to would be the active constituents that are causing the benefits or effects of that herb in the body. But in most botanicals, we simply don't know which of the markers for the plant are responsible. In some we do. The example in the last paragraph here, the senosides are the actives in the botanical senna and are responsible for a laxative effect. The amount of senosides show you how much laxative effect that herb will have. But valerian has a number of constituents, and while there are marker compounds for valerian for identity, knowing how much of those are in there does not tell us how strong the valerian's relaxing effect may be. So valerian does not have a specific known marker for efficacy. It does have a marker for identity. So that's the difference. So these are the two main categories for standardized herb extracts, whether we're looking at active constituents responsible for what that herb is supposed to do, or are they simply marker compounds that show you that it's the right genus species, the right type of plant, or the right part of the plant even, but they don't necessarily convey any guarantee of how strong that extract's going to be, as in the case of valerian. So the drug model is where you have a specific compound and you isolate it and you concentrate it, and that becomes a drug. And for example, in white willow bark, they extract the salicylic acid, and then they manipulate it, they acetylate it to make aspirin, acetyl salicylic acid. So they've taken a compound that's naturally in the plant, white willow bark, for example, and turned it into a drug. So that drug model is something everyone is pretty conscious of when they start manipulating herbs, because probably 10, 20, 30%, somewhere in there, of the drugs on the market actually derived from botanicals and are actually either synthetic versions or manipulated versions of them, or even extracts directly from botanicals. So if you're standardizing active constituents, then you're going on the basis that these isolated compounds, if isolated, are responsible for the action of the herb. That you can leave them in the herb, but measuring them shows you how strong that herb is. So you can actually be standardized to a natural strength. You'll see that on ginsengs, for example, where you might see a certain percentage ginsenosides in there. It does not necessarily mean that extract was concentrated. That might be the natural strength of the ginseng itself. For example, you would expect a 4 to 6 year old ginseng root to have between 4 to 6% ginsenosides. It doesn't go up, the same percentage, but as it's mature at that age, that's about the normal range of ginsenosides you would find in a ginseng root, just to give you an example. So it's not concentrated, even though it's an extract. So really, if you're standardizing the active constituents, the ones that are known to be responsible for the actions of that herb, you are assuring potency or strength of that formula. There's a number of things that we know are good examples. Ginkgo biloba I mentioned a couple minutes ago. Grapeseed extract has the OPCs, the active compounds in there. And you'll often see a percentage on a grapeseed extract, like 90%, 95% of those compounds. Milk thistle is standardized to silymarin. Saw palmetto is standardized to fatty acids. Turmeric, of course, to curcumin. Kava has kava lactones. These are all some of the best known herbs that contain active constituents of known efficacy. But as I mentioned earlier, the other form of standardization uses the components as markers of identity. And you typically need a full spectrum extraction rather than trying to extract certain components or concentrate certain components, because they don't know which components, or there's too many of them to try to standardize by concentrating them or extracting them. So full spectrum is really the best way to deal with that. You have a marker of identity, but you don't want to manipulate what was in the original plant too much, or you might affect how that herb affects us. So marker compounds do include echinacea, ginseng, St. John's wort, valerian, feverfew. And green tea could have both active and marker compounds. So just because it has one doesn't mean it doesn't have the other. And we actually do sophisticated testing that lets us look at a wide range of biochemical components, these markers, whether active or simply markers for identity. And sometimes it's the broad ratio of them that is the most meaningful. In terms of identity. We look at it very carefully, and it also lets us identify if something's been spiked. Ginkgo, for example, can be spiked with synthetic rutin. One of the ginkgosides is rutin, basically. So having the if you take synthetic rutin and spike it in there, you could make it look stronger than it is, but you're changing the ratios. So that's one of the things we look at in our labs, is making sure that these ratios are within the expected amounts of a reference standard. So I did mention valerian root. There's actually an article, an FAQ on our webpage that talks about testing this. And again, there's a marker compound that proves the identity but not the strength of this herbal product. This is a standard way of confirming the identity of an herb, but it does not give you any assurance as to potency or efficacy. That's why we try to get a full spectrum extraction on these herbs that have only marker compounds for identity, but they're not the actives. So an extract is made when you take a botanical and you soak it in a liquid. Typically it's water, alcohol, or probably more commonly a combination of both. And when we look at our spec sheets and we look at the flow charts and look at the documentation for each material, we typically see how much is in there and how it was done. The extract can be used, or it can be evaporated to make a dry extract. Some of them are done directly, just drying. Some of them are dried onto a substrate, a starch. Typically maltodextrin would be the most common, and that can be from corn or rice or cassava, different sources. So you can have a dry extract or a liquid extract, and we actually sell both forms, but the dry form is more common in our brand. The use of liquid extracts can be different. And this is kind of interesting because a lot of people, they don't really know the difference between liquid and dry extracts. They think this is simply a preference, but there's seems to be a principle that we can identify molecules from smell or taste, and the molecules are inhaled and sampled by sensors both in the nose and in the mouth, and it gives our brain a clue for what molecules are coming in. And similarly to how when we eat, when you smell and taste food, it kind of gives signals to our digestive tract what's coming and what does that digestive tract need to do to process and digest and extract nutrients from that food. In the same way, when you take an herb and you smell or taste it in a liquid form, that does guide the body's response to that faster than if you swallow it and the body's not sensing what it is. You don't have the same receptors in the stomach. So it's believed the liquids are going to have a different effect, partially being faster, but also being more sensitive to what's being taken. So faster acting and possibly stronger effects because of the sensory signals that are coming to the body. Same principle as aromatherapy. You're actually sampling molecules from that liquid, from that oil, and those molecules send signals directly to the brain. So you get an effect from them just by smelling them. You can get effects also from smelling and tasting liquid extracts in the same way. Now, I'll talk a little bit about our labs and the testing, since we've talked about how humans sense and test things in our bodies. First of all, our labs are International Standards Organization ISO certified as being accredited to meet ISO standards for analytical and microbiological labs. What that means is that our labs have the standards that are appropriate for testing, the same standards that any third party or contract lab would have. And these are the things that we are accredited for in our labs. arsenic speciation, which is typically not even done by most labs. This is very advanced. Acid value and peroxide value tell you the freshness of oils and fats. Metal and mineral testing is something that's done, but we also do a secondary testing on the arsenic because inorganic arsenic is much more toxic than organic arsenic. It has to do with the size of the molecule and how bioavailable it is. The organic sources have other molecules attached to the mineral itself, the arsenic, and it's conjugated into a larger mass that is a little bit different in the body, how it works. We also do pesticide residue analysis, so we're actually certified for pesticide residue testing. And something that my staff will notice when we're looking at spec sheets, that we now have specifications for botanicals where we're requiring an annual test for pesticides. New suppliers are tested for pesticides just to get a baseline before approval, by the way. Organics are tested more frequently for pesticides. In some cases, every lot, if there's something that tends to be susceptible to pesticide residue. And of course, we want to make sure that organics do not have significant pesticide signatures. And we have rejected some materials that are certified organic because we're getting hits on pesticides. And if no one else is doing this testing, and it seems to be, it's very rare that people are doing pesticide testing, then the stuff we're rejecting might be sold to other companies as organic, even though they do contain pesticides. So one of the main ways that we test botanicals is high performance thin layer chromatography, HPTLC. This is an example of the testing. This is a standard test to identify the genus, species, part of the plant, active components. This test does a lot versus liquid chromatography and gas chromatography that we mostly use for other types of materials. This is the best test to identify botanicals. This is the type of test for identity that's in the pharmacopoeia monographs like the USP, US Pharmacopoeia. This is the only test that allows us to show what is in there completely rather than looking at fractions and finding fractions. So this is the instrument used to determine strength, purity, and even instability studies to see if the compounds that we want are maintaining over time. Now, I want to contrast this to DNA testing because if you have an extract, the DNA testing will probably not find DNA, or at least not intact DNA in the sample. There's often false readings of DNA in extracts because of the way extracts have been processed, that the DNA can be damaged and denatured. So DNA testing is not reliable for extracts. The other issue is a DNA test will show if a certain genus species is in there. And we do like DNA testing for crude herbs before they're processed, but not for extracts. And a DNA test might show you, yes, there's some of that plant in here, but it doesn't show you if it might have been spiked. Let's say you're doing ginkgo, and ginkgo can be spiked, and there's other botanicals that can be spiked as well. But in the case of ginkgo, if you're testing it and you're doing DNA tests and it's spiked with one compound that doesn't have DNA, you'll never know it. You have to do the more sophisticated testing with the high performance thin layer chromatography to distinguish it. DNA testing is not sufficient for identity on extracts, and it's not sufficient to tell if something's been spiked or not, because those materials don't change the DNA. They don't contain DNA. They don't change that you're adding it to a plant that does have the DNA in it. So DNA testing has a valuable but limited benefit. for crude herbs almost exclusively, and has really no reasonable benefit for extracts, other than we might require DNA testing of the crude herb that we can get a sample of, and then we test the extract and see if they match. Does the extraction process and the material we're given reflect what should happen if that process was done to that herb? So that is something that we have looked at in products to see if they're going to be the same. This is an example of looking at mineral and heavy metal testing. This is actually something we do routinely for every raw material, and we repeat it for every blend or mix or finished product. We don't calculate the amount of heavy metals in a mix or a blend. We retest it. And having the equipment in-house and the expertise in-house allows us to do that routinely. So we are testing every raw material for heavy metals. We're retesting every blend, whether as the blend itself or as a finished product, for heavy metals. You have something like a multivitamin or a multi-mineral formula with a lot of ingredients. You don't want to rely on calculation. And we also have the headspace analyzer, it's called, that lets us look for solvent residues. It's a gas chromatograph with flame ionization detection, and it lets us look at the solvent residues. So if we say something is hexane-free, we can actually test and look for hexane and prove that it is. If we say an oil is 100% pure, non-solvent extracted, whether it's an essential oil, a food oil, a cosmetic oil, we actually have a method and equipment and expertise that allows us to test and verify that. We don't trust, we verify. And this is an example of our pesticide testing. I would estimate it's about a $2 million installation. We're probably the only supplement company routinely testing botanicals for pesticide residue. This is the GC and LC triple quads, are the short names for them. The long names are Advanced Triple Quadruple Gas Chromatograph Mass Spectrometer and Liquid Chromatography Mass Spectrometry with mass spec. Actually, 2 mass spectrometers on each one, which magnifies the results. It kind of gives us a 3D imaging that allows us to identify hundreds of pesticides. And it's fairly unique that a company would have that. It's even unique, you probably won't find this even in most university labs. And we have developed methods of finding adulterants, pharmaceutical adulterants in raw materials. This is a test we published about 10, 11 years ago. A rapid test to find adulterated raw materials of dietary supplements. We're talking about diet drugs, erectile dysfunction drugs, melamine, and steroids. Melamine is an adulterant in proteins. It fools the cheaper tests for nitrogen, which is how they test milk and things like that for protein content. We actually use a more sophisticated HPLC test for protein, and we do a test for the melamine as well to make sure that it's not been adulterated. But this test was published in a peer-reviewed journal. It was developed by our experts in our company. It's been validated by 2 studies that the references are here that have said that they have confirmed that our method is effective. I've been told that some government agencies have used our method to test raw materials for adulterants, drugs that are not supposed to be there. And one of these methods, actually, one of these confirmatory tests, confirmatory publications, I should say, called our method fundamental in identifying the pharmaceutically adulterated materials. And the way we developed this method was to get samples of the drugs and spike them at different amounts into the types of formulas that they had been previously found in the marketplace at different amounts, and then coming up with a method of reliably finding them in the raw materials. So this is one way that we screen our raw materials to make sure that you don't have a diet drug in a diet ingredients. You don't have a male enhancement drug in the men's formulas. And we've been testing pesticides for several years now, and we've developed methods of finding lower levels of pesticides than were previously possible. And one issue is that there's something called matrix interference, where something in the botanical matrix, the compounds in the botanical itself, can interfere with detection of certain things, including pesticides. And what are these matrix components that interfere? Even things like fats, proteins, and pigments like carotenoids can interfere with them, with detection, depending on what you're looking for. So this is several years ago in 2018 at the AOAC meeting in Toronto. We had two of our scientists demonstrate methods of finding very low levels of pesticides in botanicals using this advanced equipment I showed you, the triple quads, and also finding on the right very low levels of glyphosate, which is Roundup and similar types of pesticides, herbicides, that would be found in products, and which our customers are very concerned about, by the way. We are getting pretty much daily people asking about this glyphosate in materials. And the AOAC is an organization that creates official methods and is recognized by the governments around the world, including Canada and the US, as its methods are accepted as authoritative. So the fact that we're presenting our methods at their meetings and sharing them with other scientists is very impressive. And this is something that came out last summer, where we were looking at a method looked for pesticides in botanicals with matrix interference. And we were able to cut about in half the number of pesticides which were difficult to find and analyze and detect using our new method. So again, we're sharing the method. This is not just true for hawthorn, but ashwagandha and other herbal extracts have a similar complexity and are a challenge to identify the pesticides by traditional methods. So with that, I'm going to switch and talk about the first category. I've broken up our botanicals into certain categories. And just to make them manageable, there's 3 columns, a page and a half in our catalog roughly, that is showing the herbs and botanicals. And so I wanted to break it up into some kind of categorization. So adaptogens and tonics are the first category. I'll explain that on the next slide, but this is the list of products that I'm including in this category. And it's based on our label claims primarily. And so there are some botanical herbs that we do not make claims on. It just says herbal supplement. So those are going to be in the last section of the final training. But for now, we're going to talk about the American ginseng, ashwagandha, Asian ginseng, cordyceps, faux tea, holy basil, rhodiola, and eleuthero. So what are adaptogens? They're believed to stimulate the body's resistance to stress, whether physical, environmental, or emotional. Things that create stress on our bodies, the adaptogens help us adapt to them. That's from the National Institutes of Health, Medline Plus. And cortisol, which is a stress hormone produced by the adrenal gland, is probably the most well-known factor there. The adrenal glands help the body adjust to stress. Adrenaline would be one of the stress hormones that makes, for example, Cortisol is another. And cortisol affects blood sugar, affects appetite, affects body weight. So having these stresses does have an impact on health, especially if the stress is chronic rather than short-term. I mean, you can imagine a caveman, if you will, trying to run away from a saber-toothed tiger is a stress. But that stress will go away if they go back to their cave at night and sit by the fire and tell everyone how they bravely faced the saber-toothed tiger. Now, if that stress is every day and doesn't go away, that becomes a problem. So everyday stress can affect blood sugar metabolism triggered by cortisol. It can have appetite, it can make people nervously eat because of stress, and it can make obesity and accumulation of abdominal fat more prevalent. So this is a major contributing factor in overeating. So having adaptogens that help us adapt to stress is one of the strategies for dealing with this. Now, there are true ginsengs, American ginseng, and the Asian ginseng, which are varieties of Panax ginseng primarily, that are adaptogenic herbs. And you'll notice both of these say adaptogenic herb on the front, one in the green bar and one in the other. So the true ginsengs are native to the Far East, China, Korea, Siberia, and have been used for thousands of years in traditional Chinese culture, health, medicine. And according to the National Institutes of Health, the Asian ginseng taken orally helps to resist environmental stress. And that doesn't just mean environmental chemicals, it means anything in the environment that's causing stress to you, whether it's physical, emotional, or whatever. And it's a general tonic to improve well-being. So physical stamina, concentration, memory, immune function, aging process, and health complaints all can be affected one way or another by having these true ginsengs, these Asian ginsengs. Now, the two true ginsengs are the Asian ginseng, the Panax Ginseng, which you're probably all familiar with, and the American ginseng, the Panax quinquefolius, L, which are related, but they're slightly different species. Ginseng's commonly used by older people in Eastern countries to enhance their mental and physical vitality. The ginsenosides, the actives, are thought to fight fatigue and stresses by supporting the adrenal gland and the use of oxygen by muscles. And we've also seen there's adaptogenic effects of Panax ginseng on immune function. So helping to have the immune system adapt. Immunomodulation means to rev up or slow down the immune system or components of the immune system. For example, the immune system might use inflammation as a tool and a weapon, a demolition tool and a weapon, but it also uses anti-inflammatory compounds that are produced in the body to control that. You don't want out of control inflammation because inflammation is a tool. Just like we have demolition tools in the construction industry, there's also construction tools. In the same way, our body needs both. And it needs to be regulated, and adaptogens seem to have an effect on regulating the balance of the proper amount of inflammation and anti-inflammation, oxidation, antioxidation. These are balanced and modulated in the body. In a healthy body, you're going to have both. So again, we both promote and limit production of immune influencing compounds. It's a competence of the immune and repair mechanisms. Ginseng has been shown to modulate immunity by affecting cytokines, which have an effect on immunity. They affect the aggressiveness of the immune system against certain cells. American ginseng, like Panax ginseng, is also an adaptogen, and it contains ginsenosides just like Panax ginseng. And they do affect insulin and blood sugar in a positive way, according to NIH. Now, we've also blended the Panax ginseng root with royal jelly and some licorice root. Now, licorice root is considered an adaptogen. And those of you who are familiar with the DGL, the extract that's licorice root with a certain component removed, whole licorice root is considered an adaptogen and is not believed to, or has not been shown to, raise blood pressure at reasonable amounts. And when I look at, I checked the toxicology text, and there are no instances of licorice root supplements causing high blood pressure. And the amount used that would need to be used to raise blood sugar, I would estimate at around 10 grams, at about 10,000 milligrams. So this is not enough to have a concern for blood pressure. And in fact, having adaptogens with it, other adaptogens with it, actually minimize the possibility of it even raising blood pressure. So what is royal jelly? Royal jelly is a liquidy substance that's made by the bees. They are creating it as food for the queen bee only. It has carbohydrates, protein, amino acids, fatty acids, sugars, vitamins, and minerals. This is what they feed to the queen to make the queen fertile and to support the queen having all those, laying all those eggs, having all those babies. The difference is in the diet. They can turn a worker bee into a queen bee by growing that larva in a cell, a honeycomb cell, with royal jelly to eat. So ashwagandha is the next adaptogen. It's also an Ayurvedic adaptogen. It's also a free radical scavenger and has immune system support. And when we know what adaptogens do, you could see that these are all quite likely, especially the immune system support, for an adaptogen. So it's considered a tonic or adaptogen. The herb has multiple non-specific actions that counteract the effects of stress and promote wellness. Now, ashwagandha is used extensively in Indian Ayurvedic tradition due to its adaptogenic properties to help adapt to stresses, temporary short-term stresses, and may support immune function. The compounds known as withanolides are believed to be the active compounds as well as the marker compounds. They are steroidal and similar to the ginsenosides in Asian ginseng, which are also similar to the ginsenosides in American ginseng, by the way. Now, they've identified over at least 35 chemical constituents in ashwagandha. Withanolides are believed to be the actives. They've been extensively studied. They affect the GABA receptor system, which affects relaxation and calming the nervous system, regulation of the immune response, and reducing oxidative stress, including raising glutathione levels and SOD and other antioxidant enzymes in the body. But it also affects the activation of immune system cells, including lymphocytes. And so ashwagandha can help enhancing what's called cell-mediated immunity. The immune cells are regulating it, in other words, supporting the body's normal defense mechanisms. Nitric oxide activity. Nitric oxide becomes an oxidant that becomes a weapon in the hands of the immune system. activating macrophages to be able to attack other cells that don't belong there. A root extract of ashwagandha has an effect on the production of white blood cells, which are related to immunity, so it helps regulate immunity in that way. And it also has a beneficial effect on humoral immunity, which means the immunity in extracellular fluids, such as circulating in the bloodstream or other areas. And here's a study where volunteers taking standardized extract of ashwagandha, 300 milligrams twice a day. There was an improvement in fatigue compared to baseline and placebo. Their ability to cope with stress was reported better as well. And their evaluation of quality of life was shown to be improved using ashwagandha extract. And they did look at the immune activity of ashwagandha extract in 3 animal models in one study. And there was an immunostimulatory activity, increases in antibody responses, which is what you want the immune system to be able to do. And lastly, for ashwagandha, it seems to have effect on the thyroid gland by modulating the activity of the controlling axis, the communication and relationship between the hypothalamus, the pituitary, and the thyroid gland, that all release signals that is sensed and responded to by each other to maintain a balance in the body of hormones like the thyroid hormone. So here's a study, 8 weeks of supplementation with ashwagandha root extract, normal levels of thyroid stimulating hormone, and both the T3 and T4 thyroid hormones. So it seems to stimulate thyroid hormone synthesis or secretion in both animal and human research. So ashwagandha is a thyroid support supplement as well. And we do have a liquid extract, a certified organic material that is new. It's in a base of water and organic cane alcohol, ethanol. It's about equivalent to taking a 500 milligram cap of ashwagandha to taking per milliliter. There's about 30 milliliter in a dropper, just to give you a sense of strength there. And another adaptogen is Eleutherococcus centicosus, which is formerly known as Siberian ginseng, commonly known as Eleuthero, its nickname. It's a powerful adaptogenic herb. It protects us against the effects of everyday physical and mental stress. It has bioactive constituents, including its marker compound of eleutherosides. According to the National Institutes of Health, Eleuthero has compounds that affect the brain immune system and certain hormones. You can see our label claim as adaptogenic herb, but also enhances vitality. Other adaptogens are holy basil extract, cordyceps, and rhodiola. And holy basil and rhodiola are in our cortisol support formula, by the way. Now, cordyceps, the newest one of these, is a fungus used by traditional herbalists because it's energizing and adaptogenic. It has a number of compounds in there that possess free radical scavenging properties, help the body deal with free radicals, oxygen damages, etc., and support healthy immune system and normal vascular function, circulation, and the health of the blood vessels themselves. Holy basil, which helps the body adapt to daily life stress, is a sacred plant in Ayurveda. That's why it's called holy basil. And it does show powerful adaptogenic properties and response to stress, but it also seems to support healthy carbohydrate mechanism and blood sugar management as well. And it has an effect on mood, by the way. Holy basil is often used in Ayurveda as a mood elevator, or something calming to the body as well. Which when you're talking about stress and reducing the effects of stress, you would expect that. And rhodiola root. There's a number of compounds in there. I'm not going to go through all these, but you could see this is a very complex material. And there's one specifically, the rosavin, distinguishes the Rhodiola rosea from other rhodiola species. So products need to be standardized to rosavin content as an identity marker for rhodiola. And we know in not necessarily human studies, but animal and test tube studies, rhodiola affects the nervous system. At a lower amount, it's more stimulating, and at higher amounts, it's more sedating. And that, I don't know that's been studied that well, but that might not be an unusual expectation for an adaptogen, because an adaptogen, by definition, modulates activity. It can turn it up or down. So appropriately, if you take the correct amount, you might either stimulate the central nervous system to be more energetic and active, or you might sedate it at a higher amount. So, the body knows how to deal with these adaptogens, and adaptogens, since they help you adapt, they can actually turn things up or down in the body. It's not necessarily one way. So rhodiola is considered an adaptogen, regulating stress resistance, improving performance, energy, endurance. Mood support is another function of rhodiola, and supporting normal levels of cortisol, which is, of course, a stress hormone. So with that, we're going to end part 1, and hope you're looking forward to part 2, where we talk about other categories, including cardiovascular support, GI and detox support, immune support, mood, blood sugar, and even products with no claims at all, that will at least go through and show you what they are as part of this process. So thank you, and we go back to Sue.
Wow, thank you. Thank you for that great introduction to the wonderful world of herbs. There certainly is a lot to know. And that's why we have a three-part series. So I want to remind you that this was part 1. We will meet again next month on July 21st at 2 p.m. Central for part 2. And Neil will focus on the next category of herbs for mood, stress, sleep, brain, memory, free radical and cellular protection, and much more. So watch your email for login details for the next monthly webinar. And I thank you once again for joining us, and thank you, Neil, for an excellent presentation. We'll see you all next month.